An attempt at an algebraic solution to this problem leads to an inconsistent solution. Why does that occur? Well, let's actually look at the solution that's been provided. We have the square root of the quantity x plus 2 minus 1 is equal to the square root of the quantity x minus 1 minus 2. The first step in solving this problem would be to add 2 to both sides. That's how the subtraction of 1 on the left becomes addition of 1, and there's no constant of minus 2 at the end on the right here. Now that we have a square root of a quantity, we can square both sides in order to get rid of one of the square roots. And when we do that, we need to distribute, or you could also write the binomial 2 times and distribute. So we have the square root of x plus 2 plus 1, and then the square root of x plus 2, and then plus 1 again. So when we multiply the square root of x plus 2 times the square root of x plus 2, we just get x plus 2 by itself. And then when we multiply our first term, the first binomial, by the positive 1 at the end here, we get 1 square root of x plus 2. Then we get another 1 square root of x plus 2. That's how we have 2 of them here. And then when we multiply 1 times 1, we end up getting 1. And now if we combine our like terms and move things to the left and or right hand side, for example, subtracting x from both sides, well, they end up canceling each other out. They go away. And then if I combine this 2 and this 1 together, I get 3, and subtract 3 from both sides. That's how we get negative 4 on the right hand side, and all we have left is 2 times the square root of x plus 2. If we divide both sides by 2, we get the square root of x plus 2, which is equal to negative 2. Well, because there's no sign in front of the square root, it is assumed to be positive, and the square root of any number, when there's no negative sign in front of it, cannot be negative. Therefore, there is no solution. Now, why does this occur? Is it A, that there is no solution because the graphs do not intersect? Is it B, there is no solution because of the domain? Or is it C, there are infinitely many solutions? Well, in our original problem, we have this function is equal to this function, and we're trying to figure out where that occurs. That means we're trying to determine the x value where the two functions intersect. And if we actually look at the graph of these, here's the left side of our equation, and here's the right side of our equation, we can see that both of these square root functions appear to never intersect one another at all. Even if we were to continue going this way, they're not intersecting one another. So therefore, the correct answer here is choice A, that there is no solution because the graphs do not intersect.